Welcome back. So now I want to show you how you can use alter ego with oTree. This can be quite interesting if you want to run experiments with humans and machines, because it allows you to sort of get responses by machines and put them back into your experiment. So what I have here is my project folder in oTree. And let me actually tell you what it looks like at the moment. So if I execute tree, basically here I have the usual database file. Here are two apps I will show you in a second. We don't have to go into that right now. Here is my OpenAI key. That is important. So please put it on the top level of your project folder. And here is the settings.py. So within that settings.py, I created two session configs, ego human and ego chat. And first of all, let's look at ego chat, which is a very simple chat with GPT. So let's actually run oTree dev server. Well, let me actually start my environment first of all. So I installed oTree in the meantime. Now we can do oTree dev server. And once I go to the browser, you will be able to see this. And now let's go to the chat. Let's open it. First, we are being prompted to enter our name. This is just to show you the templating capabilities of alter ego, thanks to Ginger 2. So here I will enter my name, Max. And what happens now in the background, or what happened, is that the system prompt was put into the agent attached to the player object. And the system prompt basically looks like this. It says you are an AI. Today you are interacting with a real human who goes by the name of Max. Although in the actual prompt, this is, a placeholder. As you will see in a second, always be polite and courteous. So now we could sort of interact with GPT-4. For example, we could say, how's the weather? Obviously, GPT is not able to answer that question, but let's see what happens. So here you see a very nice loading spinner, which we implemented. And now you see that GPT does not really respond, but in actuality, it does remember the name. So here you see that actually this system prompt really was put in, and it is as if GPT was now chatting with a real subject. Okay. So for example, now you could say, write a very short poem about LLMs. And then after a couple of seconds, we will get a very nice poem, I guess, about LLMs. Yes. And there it is. Very nice. You basically can customize this app however you want. Probably you would want to sort of erase this text after sending it. And you might want to have it so that it's submitted when you press enter. But you can do that. This is just a very simple example app for you to sort of look at. And let me actually show you how this is implemented. So if we go back to the editor, and if you go to the ego chat app, the init.py in that app, we see that we have some extra imports here. And those are pretty much the imports from the GitHub page. And let's go on. So what happens once the session is created, what we do is we associate with the player object a GPT thread. And here we have the model GPT-4. So you could also, associate threads and conversations as well, by the way, with players, groups, participants, subsessions, and sessions. And this is supposed to be all, persistent. The attachment will last for as long as the object is alive. So for example, within each round in oTree, or within each app, meaning within each subsession, the player object is sort of restarted, you could say. A new player object is created. And therefore the attachment would be lost. However, if you associate the GPT thread with the participant, then it would last for the entire experiment. Okay? So that's what we provide you with. So you see, we are almost halfway through now. So you see the entire code is quite simple. We put in this name field, this name string field, so that people can put in their name. And that exactly is what happens here on the welcome page. And as I said, we basically put in the name to the system prompt. So let me actually show you how the system prompt looks. Let me show this to you. So you see, it basically says what we saw earlier in the browser, but here we have this placeholder, player.name. And the nice thing is that within this prompt, or within any prompt with alter ego and oTree, you can directly access, fields on the player. And because you can access the player in that kind of way, you can also, access group variables or do whatever you want. The only thing you need to do is you need to open the context, as we say. You need to open the LLM context, which is done using the with statement. So you do with AI of player as LLM, and then you can do whatever you want. You can do LLM.system. That sets the system prompt. Here we read the inf from a file, and we pass it the player object. Okay, and that makes it possible to recur to these variables inside of the prompt. Okay. Yeah. By the way, this from file is just a very simple utility provided by alter ego. Of course, there are a million other ways you can put in the prompt. What you can also do, you could also remove this, and you could actually put the prompt straight into your app by doing this. So that would also be possible. Okay? And you can pass arbitrary objects to the prompt, whatever you want, pretty much. But typically, the player object or the group object or the session object, they will be most useful. Yeah, and that's pretty much it, actually. So what we have on the chat page, which I can also show you very briefly, on the chat page, we have some sort of extra, some extra gags, okay, some extra gimmicks. For example, this loading spinner is embedded somewhere. And most crucially, the history is sort of printed out. Okay, and you can look at how this is implemented. But this is just so that if the player reloads the page, the history is once again printed out. And once the player submits a new message, it is sent over to the server. And how this works is as follows. Pretty much once you click the send button, the send message function is triggered. And the send message function basically sends over the value of the field over to the server using live send. And once live send is executed, this triggers the live method on the page, which is this right here. And within that live method, we check whether what was submitted is actually a string, meaning whether it's actually a valid message. And if so, we sort of, again, open this LLM context using with. We submit the message that was actually put in. And we have this limit of like 500 tokens here, but you can change this. And then we get a response back from the large language model, GPT-4 in our case, which we then return to the page. Okay, so this here is just perhaps somewhat confusing, but this is just oTree notation to return certain data to the page. And what happens is we have the live receive function here. If it was successful, meaning the first element of data is true, which is the case here, then, a message is added to the chat and we sort of release the button so that people can submit the next message. So you can look at the code, how it's implemented, but these elements are the most crucial parts. Okay. We also have here an unimplemented branch of this if statement where you can also handle errors. So for example, there could be a situation where you might return false here, and then you could sort of return some extra error message. But for reasons of simplicity, we sort of keep it very minimal here in this example. So hopefully that sort of illustrates how you can use an LLM within oTree. And actually, what you can also do is you can pass this LLM object as a VAS4 template. And the reason that can be useful is here, for example, to access the model. You saw that we had the statement, you are chatting with GPT-4 at the top of the page. So that's what this is for. And you can access all parameters on the large language model object, on the thread to be precise, by using this notation, okay, as expected in oTree. There's also this HTML history, which basically allows you to get a nicely marked up version of the thread's chat history, okay? So that's how the chat is implemented. Again, lots of bells and whistles, but still quite minimal. And Python-wise, it's really, hopefully, simple enough. What you need to remember is that you always need to use this context management to open sort of the space for the LLM to become active. Okay, so much about the chat. Let me show you a more complicated example. Let's again start the dev server. Let's go back to the browser. And here we have Ego Human, and that was actually the human-machine interaction experiment that we had in our paper, which you can check out on GitHub. This experiment is also available on GitHub, so you are also free to check it out. And if you click Ego Human, you will be put into a situation where you will interact with an AI. So this is like not a chat, but actually a discrete choice experiment within the group, and with a human player and a machine player. Actually, the machine in this case is also GPT-4, and GPT-4 in this case represents the first mover. And let's have it move, I say. And we don't have to read through this. So this is basically just a framed prisoner's dilemma, and you can find more information in our paper, okay? So option 1 is basically to cooperate, and option 2 is to defect. And if the other person defects and you also defect, both get a low payout. But if the other person cooperates and you defect, then you get a large payoff. The temptation payoff, as it's called. And, the AI is the first mover in this game. So you see the AI just started out to cooperate. And now the human player can also choose what to do. So let's also continue cooperating. You see the spinner again. And now in the second round, again, the AI cooperated. Okay? And this here is the joint enemy frame, which stays constant for the whole experiment. So let's again cooperate and so on. But once you defect, you see what you could call some sort of intelligence by GPT-4, because now GPT-4 actually also defected. But now let's try to mend relationships. Let's try to play option 1. But actually, there's a lot of distrust now. And that is also something that we found in our human-machine interaction, is that once the human defects, it's very, very difficult to get back to a situation where both players can cooperate. So that's too bad. But perhaps at now, play option 2. Option 2. Oh, now actually the AI also played option 1. So we once again were tempted, you could say, or we didn't notice what happened. But let's give them some extra money. So you see, this is a very, very simple, very Spartan experiment, you could say. And then this goes on for 10 rounds. And then you see here a final feedback for the 10th round. Okay. So that's the Ego Human experiment. Let me show you the code. Here you have this experiment where you have these payoffs that we just talked about. Basically, it's also quite simple, but there's some extra stuff, but we don't need to talk about it that much. So for example, let's completely skip the dropout stuff, and we can also, let's not talk about the clear pay amount. This is just something for our lab to do the payments, okay? But what we do in the first round is we associate the player with a treatment. We have 3 treatments, which are called 1, 3, and 4. Then we create the LLM, which is a GPT thread with GPT-4, as I just mentioned, which has the name AI. And the human is an external thread. And we bundle these two threads together in a conversation. And then at some point, we associate the conversation with the participant object. So you see, we played this over 10 rounds. So here we use the participant object because it needs to stay constant for the entire experiment. Okay. And here are some other, information. Here's some other information that we put into the conversation. We start out with a few system prompts. So here, for example, is the prompt for humans, system H, in the treatment 3, actually, the joint enemy treatment, which we just saw. And you see here the variables that we talked about in the video on the builder. And you see it's quite straightforward. These objects here are just defined by the conversation, and you can just access them from within the prompt. Okay? And you see the human being is also told that the AI is actually an artificial intelligence. So the system prompts vary a little bit. Okay? And we do the very same thing for both the LLM and for the human, and you see the prompts are different. Okay? And they depend on the treatment that people are exposed to. Okay? So what we do within each round, meaning every time the player object is renewed, we also save the LLM's ID so that we can sort of easily find it later on in our files. And we sort of have this treatment variable. We have a choice, which is to cooperate or defect pretty much, but we don't use any framing there. And we also, for reasons of simplicity, save the other choice. But that's not strictly necessary. That's just for convenience. So once the first mover plays, we sort of, again, invoke this context. We get a single number from the first mover, which is basically, we want to see option 1 or option 2. And obviously, 1 and 2 are numbers, so we can just extract these numbers. We also give the LLM the opportunity to refer back to the player object from within the prompt. Okay? And so then we set sort of the other choice, meaning the AI's choice on the player object to the actual response by the AI, meaning the filtered response, as we say, because again, it's just a single number. And then we submit the prompt for the second mover. So the prompt for the second mover looks like this. Might look a little bit complicated, but actually it's quite straightforward. Basically, if we are in round 2 or above, we sort of have some feedback about the previous round. Then we ask, what do you want to do? And that was what you also saw in the browser. Okay? And again, here you see the common enemy framing. Yeah, and that's pretty much it. So we don't need to talk very much about the start page. That's simple. Here within this second mover, we always invoke the first mover function, which is this function here, because we have multiple rounds, as I just mentioned. And then again, we add some sort of eye candy, which is the history table that you saw in the browser. Okay, and then that's it pretty much. Yeah, I think so. On the page where people make their decision, we also, of course, add up the payoff. We determine the payoff of the human being and the large language model. And that is sort of important to know for future rounds. And also for the humans who are actually being paid, of course. Yeah, and then for the final round, we can also submit this result, which was shown in the browser as well. Yeah, and that's pretty much it. The rest is pretty much boilerplate oTree stuff. Now, one thing that is perhaps important for you to know is that alter ego, if you use it with oTree and if you open the context with, then the message history is automatically stored in the ego output folder. So let's go there, ego output. And here you see all the various sessions that you ran earlier, okay? So right now we ran the XN, there it is. And we just had one player, one conversation. And here you see both players' message history as JSON. So let's see, actually, JSON tool, I think that's how it works. So this, that's actually the AI's message history that we see here. Right, you are AI, and here you can see all of the messages that sort of happened, okay? And here you see, again, the common enemy framing. So this is sort of important for you to perhaps check whether everything worked correctly. And if you go to the human player, then it's not as interesting. But here too, you sort of see the results. But the human player sort of is captured by oTree. The machine player is captured by this message history. And also because of this other choice that we had, that we record up here, right? So that's how you can build experiments using alter ego and oTree. Remember that the output is always saved in .ego output in your project folder, and that you always have to use the context, which you can open using with AI, and then the object to which you actually attach the thread or the conversation. So I invite you to look at our code and try out these experiments yourself. And yeah, enjoy. Thanks so much for your attention.